Flack math! Give me some math and I'll give you some flack. Flack math!
One of my favorite things, which is multiplying and dividing rational expressions. How do you divide fractions, Matthew?
By dividing them. Oh,
I know.
Xavier.
You're new. That's okay.
I know.
Jace?
Me.
How do you
Copy that flop.
copy it off up? The real answer, what's the Xavier answer?
You don't.
You don't. You don't ever
That's his
divide
answer for
fractions.
everything.
Never get into that weirdness. You gotta turn it into a multiplication problem. Copy dot flop. Okay? So number 3, 2/5 divided by 1/20 is just 2/5 times 20 over 1. You can cross reduce, do all that, and you get 8, or you get 8 for number 3. Number 2, same thing, you can cross reduce. Don't miss out on the fun and the therapy of cross reducing. It's so therapeutic. So 3 and 9, 1 and 3, 5 and 10, 1 and 2, you get 1/6. Otherwise you get 15 over 90, and who wants to reduce a big fraction like that? You guys are weird. And you ended up not getting it right. Because
I wrote a 3 really weirdly.
I
That's
know,
why.
it's just it's too much room for error. Okay, rational expression is undefined if its denominator is 0, okay? We don't even talk about it. We don't even like to mention it. All right? Okay, moving on. Here we go. Let's multiply and then evaluate here. So this will be fun. This will be very therapeutic. Here's example 1, 5ab squared over 6b squared times 12a squared b squared over 3ab to the third. Okay, I'm going to take out my red
That's a
pen.
bad 3. Fix that.
It'll go away in a second. So the beauty of this is you can cross reduce and you can vertically reduce. The only thing you can't reduce is horizontally. Okay, so what are some things that can reduce?
B squared.
The b
Left
squareds
side.
immediately can be reduced.
A.
The a, with this a right here, yep, cross reduce the a.
And then the B.
You could have cross reduced it there. You still would have ended up with the same answer. But there's no more a's to cancel, so you're done with the a's. But what about the b's here?
You can get rid of the top one.
Yep, and how many are left where?
One on the phone.
Just one on the bottom. So you can just do this, and you can do this. Okay, does that make sense? Because BBB on the bottom, BB on top, 2 B's cancel, and you're left with 1 B on the top. Now let's go numerically. Let's cross reduce numerically, Austin.
6 and 12.
6 and 12, that's the only thing so far. And then you could have done the 3 and the 12, but you still would have ended up with the same answer. All right, and that's it. The 5 and the 3 and that doesn't, and the vertically it doesn't. So what do you got? 10 a squared all over what? Just 3b?
Yeah.
And that's it. You can leave it like that.
Yay.
Or if you wanted like a separate coefficient, then you could have just said 10/3 a squared over b, or 10/3 a squared b to the -1 or something. Okay? So pay attention to how they want you to write your answer. But then here's what it says. Evaluate for a equals 4 and b equals 5. So just plug it in. So a squared does not mean a times 2. And if a is 4, what's a squared?
16.
16. So this is 10 times 16 over 3 times 5. So that's 160 over 15, which is what? Do you know what 160 divided by 15 is?
It's like at least 12.
10.6666666666666.
Dang it!
It's like 10 and 2/3. Okay, but you can reduce by 5. Oh, I just spit on myself. Oh my goodness, it's like bad. So if you just take 5 out of it, then what is that? 32 over 3. 32 thirds.
There's at least 12 on top.
Yeah. Yeah. Okay. Let's try another one. This is more fun. I really like this. They just keep getting more fun. All right. This was very therapeutic. I loved that. It was great. And here's the other thing you have to do. Before you cancel stuff, even though you canceled it, you still have to account for it. Guess what? A can't be 0 and B can't be 0.
So if I don't write that.
Right? If you don't write that, then it's naughty, but I won't mark it off. But if you write it without me telling you you have to write it, then that's extra credit. Okay? And there was a couple of things like that on the test that you just took. All right, here's 1B. 15x minus 3x squared over x squared minus 9. Oh, it's going to be so good. X squared minus 8x plus 15 all over x squared minus 10x plus 25. This is my favorite chapter in the book. Favorite. Okay? What do you do first with the green pen?
Get rid of X's.
You can't get rid of the x's because they're being added and subtracted and stuff. So what would you do first? You have your hand raised, Austin?
I did, but I know.
Okay, Sarah, what do you think?
Could you get rid of the x squared?
Can't get rid of anything yet because it's being x squared subtract something. So see how like if I had a 5 plus 2, I couldn't cancel.
Yeah, I see.
All right, Javon.
You put parentheses.
So what is that called? It's an F word.
F-bomb.
Not F-bomb, but you're factoring it. So when in doubt, factor it out. Whenever I see a trinomial, I have this major urge in me to factor because it's so fun. It's the best part of math, any math, just factoring. Okay, well, what are the steps to factoring? First step, look over here, look for a GCF. Let's deal with that first. What do these two things have in common?
3.
Numerically and literally.
At least 3.
3, and what else? They have another thing in common.
X.
They have an X. You can take an X and a 3 out of both of those. You guys see that? So let's put a 3X over here and then say what it's left with. Well, this, if you just multiply by 5, you get back to 15X. And then let's see, this is just an X. You see that? Everybody good with that?
Yeah, that's pretty cool.
Oh my gosh, did it start with this? All right. Whatever. Okay, so then over here, so that's done. So I'm just going to kind of lightly ignore that. What about this? X squared minus 9. How do you factor that?
Can you?
You can. Do you know how?
Would you put an invisible?
A 0x, you could there. But the shortcut is, how do you factor a difference of 2 squares? This is what this is. Difference of 2 squares.
So it's x minus 3, x plus 3.
That's it.
Oh.
So it's
Oops.
it's the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. That's it. All right, I'm going to lightly ignore that. All right, what about this? This is a trinomial. Cheeks and tats. What's the magic question?
What adds to 15 but or adds to -8 but multiplies
Okay.
to positive 15?
So that scenario is weird. How do you add to a negative number but multiply to a positive number?
Will you add 2 negatives?
Yeah, it has to be 2 negatives. Okay, so what 2 numbers multiply to get 15 but add to get 8?
-5 and -3.
There it is. -5,
At least
-3.
12.
Okay? What else? What about this?
-5.
Yep, -5. That's a square trinomial. Okay, now, normally I would just start going nuts here. Okay, so the x minus, this is one factor. It's a chubby factor, but it's a factor. You can only cross cancel when you have all the factors listed out, okay? So you can only cross cancel factors of the complete numerator. So see how this numerator is now just 2 factors. So you can cancel those. You can also cancel one of those. What else would cancel?
Can you cancel x minus 5 and x?
Good
5 minus
question.
X?
No, because what happens when you reverse a subtraction problem?
It becomes a
Bad.
addition problem.
Well, it's not the same. You can't do it. You can't reverse a subtraction problem like you can an addition problem, but it becomes something specific. What's 5 minus 3?
Negative.
It's just
Negative 2.
2. What's 3 minus 5?
negative 2.
Negative 2. So it just changes the sign. So here's what you could do. I could rewrite this. Yeah.
I need to go to the bathroom.
Okay.
Just walk away like you usually do.
Oh.
You may go. You may go. Okay, so here's what happens. So I could reverse that as long as I put a negative sign in front of this. So this is negative 3x, x minus 5. Okay, we'll talk about that a little bit later, but you can reverse a subtraction problem as long as you put a negative sign in front of it.
Okay.
That's all we did. So now we can cancel another x minus 5. So guess what we're left with? We're just left with, the only thing on top we're left with is this negative 3x, and on the bottom, just an x plus 3.
Yay.
Okay?
Nice.
But x can't be 0.
All right.
Oh!
X can be 0, but what can't x be?
X can't be through negative 3.
Okay, now, if you were just looking at the answer, right, but you have to account for all the steps. So after you factor, that's when you figure out what your exclusions are. It can't be 3, it can't be negative 3, it can also not be 3, and it can't be 5. You see that? You have to account for all of those. The numerator doesn't matter, just the bottom number can't be 0.
Okay.
Oh.
Yeah.
So before you cancel, you still have to account for that. Because that would have, a 3 or a 5 would have still messed up that problem. It doesn't mess up this, but if it messes up anywhere in the process, then you can't have it.
Okay.
Okay, and it just keeps getting better, guys. It just keeps getting better. Here's 1C. This is great. This is great.
Uno set.
What?
Uno set.
Uno say? That doesn't make sense.
Because C.
Yo no say means I don't know. Uno say means like
No. Say.
One.
Different spelling.
Isn't the C hard in Spanish?
No.
there's
How do
no
you say
C
the-
in say.
How do you say the letter C in Spanish?
Say. Oh, uno say. I get it. Thank you. You're right. I'm wrong. I forgot that. How? What percentage are you?
2%. Okay.
No, you're more than that. You're right. You're 2%.
Alright.
He's a little sensitive about that. He was hoping for more.
My 2% came out.
Yeah,
in
that's
that
right.
moment.
I'm sorry. I shouldn't have even argued with you
Yeah,
because I'm
obviously.
0%.
Yeah. Mexican.
Oh.
Yeah.
Are you seriously like sad about that?
I mean,
'Cause I don't-
At
I
least
want-
I'm still black. I said that correctly.
I definitely have some German. It's so sad.
We're also born in Germany.
Yeah, but that's like, we don't talk about that.
She doesn't like the Germans very much.
Wow, really?
I think it depends on the German, just like it depends on anybody.
It does depend on the German, but
Nope.
90% are still.
Wow. Okay, you didn't hear that.
Oh, that's on YouTube.
All right, hold on. I'll erase the brains. Okay. All right. So before you start, let's just factor it all out. Let's just go nuts right now. How do you factor this?
Divided by.
You can take a 5 out.
Oh yeah, that one.
You can
X
take a
plus
5
2.
out.
You can?
All right. What about here? Ooh, that's a one of these guys, which is a little annoying
Oh.
because it's not x and x, it's 3x and x. So you have to figure out what multiplies to get -1, but then when you FOIL it out, we'll combine the 2x.
1
Do you guys know?
Is it one
and
over
negative
X?
1.
It has to be 1 and -1. That's the only thing that can equal. But is it +1 here and -1 here, or is it -1 or +1 there?
There's a 50.
It's plus and then minus.
It's minus and then plus. Because
Nuh-uh.
Let's go.
Look what
That's I wrote
happens.
down.
Because when you FOIL it out, this is a positive 3x and a negative 1x. That combines to positive 2x. Does that make sense? When you FOIL it out, you'll see it.
Yeah.
So if these are still not making sense to you, do more of those. And check your work. Checking your work doesn't just check your work. It helps you learn these types of problems forward and backwards. Okay? That's where I think that's where that saying comes from. You learn it forward and backwards from factoring trinomials. Maybe not.
Yeah, that's probably where it came from.
Okay, what about this? Guess what? This is a difference of 2 squares. How do you factor a difference of 2 squares?
You don't.
Square root that. Square root that. One of them's plus, one of them's minus. Boom, you're done.
Okay.
Okay? This one you can't factor. There's no common factor. It's not a difference of 2 squares, and it's not a factorable trinomial. Those are the only 3 things you have to check. Over here, same thing. You can't factor that. What can I take out of both of these?
5.
5. So 5 goes in 3x plus 1. Look at all these 3x plus 1s that can be canceled. So you can cancel that. Whoa, look at this. Oh my gosh. Therapeutic.
So
Therapeutic. X plus 2s.
Okay.
The 5s. Oh my gosh.
The X plus
This is
one.
exhilarating.
X plus 1s.
X plus 1s. Oh my gosh. What are we left with? Just nothing. 1 over 1, which is 1. So don't put 0. It's 1.
Oh. Watch.
I gotta reapply my blood.
He will.
Okay,
You had that at
that was uno say.
Who knows that?
I can't believe I doubted you.
That doesn't make sense, Mr. Flack.
That doesn't make sense.
Isn't it? It's.
What character have you dressed up as?
Have you
Mr.
seen
Black?
Stranger Things?
No.
I'm 11, the little bald girl. I figured, hey, I already have half the costume,
Did you make it work?
so I might as well complete the ensemble.
We didn't even predict.
Next year can you be
Well,
Mr.
nine.
I thought you were gonna go
Mr.
with
Clean, I gotta work out.
We were going.
I gotta work out between now and then, because he's pretty
Yeah.
cut.
It's gonna be so much.
All right, that's awesome. That's just exhilarating.
Yeah.
Nobody gets it.
Okay, so now we know how to multiply. Guess what? You now know how to divide. Because how do you divide fractions, Matthew?
You don't.
You don't. You copied out flop that crap. Okay, so let's try another
No, you mowed it down.
example.
Wow.
If Sarah's ready. Is Sarah
Only
ready?
if she's ready. Are you ready now, Sarah?
I'm fine. I'm ready.
I'm
Are
fine.
you though?
Okay.
Okay.
X plus 1 over x minus 2 divided by, we're not afraid, x squared minus 3x
At least he didn't write divide.
all
by
over
zero.
x squared minus 2x.
Divided by 0.
Oh, we forgot to do that in the last problem, to declare our exclusions. So embarrassed. I got so wrapped up in
Bad
everything
thing.
canceled. It's just beautiful. Okay, where can I start factoring?
You got a copy.
Yeah, you got to copy dot flop first. So here's my shortcut, if this is weird. I'm going to factor this up here, and I'm going to factor this up here, and I'm going to change that to a multiplication symbol, okay? So
Okay.
this factored up there, you can take an x out. And this factored down here, you can take an x out of there. Does that make sense, what I did?
No.
So I
Yes.
still flopped it, but I flopped
Oh.
and factored it. I double left it. I flopped and factored it.
Wow.
Okay? I effing factored it. flop and factored it. That's what I did.
Wow. That's cool.
Wow, that's inappropriate. That's what you were thinking. You were disappointed in me. Okay, what can cancel?
The
X minus 2.
All right,
X minus
Austin.
3.
Yes, Austin. What else can cancel? A lot of people miss this.
Ha,
The
like the
better
use of the
version.
off-brand version.
X.
Yeah, just the X's here. right? Because that's a factor by itself. Because see, do you guys see with your eyes the two
No.
factors? There's x multiplied by x minus 2. There's two factors. If this can be canceled with a factor below it or diagonally, then you can cancel it. All right, so what are we left with? On top,
X plus 1.
x plus 1 over
1.
x minus 3, bt dubs. What can't x be?
-2, -3.
No.
Or,
You see why it's positive 2, positive 3?
Oh, yeah. Because if
Okay.
X was +2.
Yeah, and then x, 0. If x was 0, that would make this factor 0. So you want to make sure none of the factors would equal 0. So if x is by itself as a factor, then that x can't be 0. This x can't be 3, and this x can't be 2. Okay?
Okay.
That's it.
Mr. Flack,
Yeah.
I feel bad. I used 2 free problem sets.
In a week? Oh, Javon, that is not. Can you make a call?
One for geometry and one for algebra 2.
Sarah did it.
I'm sorry, I did the tests. I'm pretty sure I failed them.
I'm pretty sure.
You're pretty sure.
That's what you say a lot.
I know, I say that every time I do
You're
the
And then you don't.
And
Big
I
fat
don't fail.
liar.
Maybe it's because I say it.
Yeah,
Maybe.
that's why.
So I need to be less confident.
Self-degradation. Yeah. I think that works. Okay, do you guys want to do one more? These are fun.
Only if I win.
Okay, free problem set? Let's do it.
No.
That's not what I just want to win.
Before you say go, write the whole thing down.
45 over x squared plus 2x minus 15 times 2x squared plus 10x over 5x squared y divided by 1 over x minus 3. Ready, go.
I hate this.
I win.
I got it. Let's see what
Is
the
that
answer.
5x cubed or 5x squared in the second one?
Everything's squared, like there's no cubes. Yeah, 5x squared y.
Is there anything in them?
No, we took them out and put them in the freezer, but we did buy them last night. King Supas. Joel took them from me. First period or second period, I can't remember. And then I was able to say Lego my Egos. Do you guys remember those commercials? They were a
Yes.
They were a thing.
I think I saw like 2 ever.
Yeah.
It's going great.
Yeah, this is like buy Egos. Click the link below for more information. Just kidding. It's not. There's no link below. I'm not gonna put it. Maybe I will. Maybe I will. Copyright. I'll get copyright. I'll give you a hint. This is pretty therapeutic. Not completely therapeutic, but pretty therapeutic.
Mr. Flack.
Weird why.
Yeah.
Is it this one?
If you haven't,
You got it, Matthew. You got it.
Parts of that are right.
Okay. I
Parts-
will make it better.
You're missing something, but you also
yeah.
have not simplified it.
Yeah, I see. Is this one it?
is it? Darn it. the next one.
Technically,
Can I see what you did?
you're not done, but
Okay,
Actually,
that's just what
you can't read it.
I can't.
It's just this part. I can't even read it. It's just a regular calculator. It's just a regular calculator.
just a regular.
No, it's more complicated than that.
Yeah, but like yours is just like a regular. Mine's like regular.
Wow, the coolest.
Yeah, it's so much better. This is the best kind of calculator.
Well, if you have it in your brains, you don't need to have the calculator. It just takes long.
Well, if you had your brains, you would get a better calculator.
Never mind. You know what this is American saying? I hate when Barter's my whole work smarter, not harder. It's the most stupid saying. Because if you're gonna work smarter and harder, you're gonna achieve more than if you just work smarter.
Yeah, so why don't you do either?
No, you work. Never mind. It's just it doesn't work.
I know. But I would rather work smarter than work harder.
I'd rather do both.
Well, I would do both, but I'd
You would rather.
rather work smarter because then I have to do less work.
Yeah,
And the state amount of stuff happens.
I guess.
okay. Let's do this real quick.
Okay.
No, let's not. You know what? We can just move on. It's
She accepts this.
Let's. The only thing that can be factored is this guy. So what is that? Plus 5, minus 3.
yeah.
And then this one, you can take a 2 out, and then you can 2 and an x out, and you have an x plus 5.
I did that right.
Okay, and then you have this, and then we're gonna just cross this out, put an x minus 3 over here, and then a 1 down here if you want, but you don't need that one. Okay, so this x minus 3 can cancel, this x plus 5 can cancel. One of these x's can cancel with one of those. And then this 5 can cancel with the 45. All right, and then I'm left with 9 times 2 on the top, which is 18, and then x times y on the bottom. Okay, so this is the right answer, but what else do you need to do?
X cannot be negative 5, positive 3,
Negative 5,
0.
0, and positive 3, right?
Yeah.
And then y
Y
can't be
0.
just 0. Okay, that's it. All right, so that's lesson 31. Moving on to lesson 32. We are going to talk about inverse matrices, multiplicative inverse matrices. Okay, you guys remember what the identity matrix is for a 2x2 matrix?
No.
1, 0, 0,
Yep,
1.
so this is the identity matrix. Let me get this up here. So 32, I get ahead of myself, I get so excited. Matrix inverses. Okay, identity matrix. It's like 1, 0, 0, 1. If it's a 3x3, remember it's just 1s all the way down diagonally, and so on. Okay? So right now we're just going to talk about the inverse of a 2x2 matrix. So here's what happens. And they start with a couple different examples, verifying inverses. So let's try like P and Q. Let's say P equals 2, 6, 1, 4. And Q equals 2, -3, -0.5, and 1. Okay? So if these were inverses, when you multiply inverses together, you're supposed to get the identity. Okay, so let's try that. Let's try multiplying P times Q. So let's see, we get 2 times 6, or 2 times 2. Remember, we do this thing. 2 times 2 is 4, and then -1/2 of 6 is -3, so 4 and 3 is going to give you 1. Okay, and then 2 and 6 times this column, so -6 plus +6 is 0. Okay, and then I'm going to take 1 and 4, so 2 plus -1/2 of 4 is -2, that's a 0. And then 1 times -3 is -3, and 4 times 1 is 4, so that's going to give me a +1, so that works. Now let's try QP. What's QP going to be?
The same.
Well, no, and this is
It's gonna
what's
be inverse,
weird.
it's gonna be 0, 1.
So
1, 0.
multiplication and matrix multiplication is not commutative. So look, this time we're taking this and we're multiplying by these columns.
Of course. it
So
could've been
4, basically 4 plus -3 is 1. All right, and then we get 12 plus -12 is 0. All right, and then we're going to take this. -1 plus 4 is going to give us,
3.
well, this is actually going to be, this does work out the same. Right, so you got like a -1/2, right, plus, did I write that? Oh, I'm doing it wrong. Yeah, -1 plus 1 is 0. And so that does end up being the same. And that happens when it's identity matrix. But let's try a couple more examples. So here's what the deal is. Why are these multiplicative inverse? Do you see what we did? It's so hard to be able to, if you can figure this out, kudos to you, but it's so difficult to figure out. So I'm going to find the inverse. Using P and Q, I'm going to find the inverse of this. Here's how you find the inverse. You ready? To find the inverse of a 2x2 matrix, it's this. So the inverse of A, which is a 2x2 matrix, is 1 over the determinant of A times, and this is where things get weird. If A is A, B, C, D, what you do is you switch A and D, and then you negate B and C, but you don't switch them.
That doesn't make sense.
I don't understand.
It's not going to make sense. But this is what happens. It will make sense when you multiply it out, like what we did, because you want to get this identity matrix when you multiply it out. But write this down. 1 over, it looks like the absolute value of A, but when it comes to matrices, it's the determinant. So if I took 1 over the determinant of P times, and then I'm going to switch these around, 4 and 2, and then -1 and -6. You see what I did? I just swapped the 2 and the 4, and then I negated the 1 and the 6. So what's the determinant of P? 8 minus 6, that's just 2, right? So it's 1/2 times this matrix will give you 1/2 of 4 is 2, 1/2 of -6 is -3, 1/2 of -1 is basically -0.5, 1/2 of 2 is 1.
That is exactly what was up there.
And that's what's there. That's what Q is. Yeah.
Why?
Because
Wow.
when you multiply it out, you get that. And this is what, and so you don't have to understand why, other than if you want to think backwards on how we multiplied all that out, then it kind of makes sense why a little bit. But for now, let's just write this down. This is what you need to write down. To find the inverse of any matrix, that's what you do. This will be on your next test. Maybe not your next test, maybe the one after. But you need to write this down. And you can use this if you want. The inverse of A, which is A, B, C, D, is 1 over the determinant of A times swap A and D and negate B and C. But don't swap B and C, and don't negate A and D.
Can I make a picture of it because it makes more sense to me with everything else?
You can take a picture of it, but
No, she
it would
wants to
take
make a
you
picture.
it'd take you a while to make a picture of it.
You know what, guys? Whatever.
I want to make a picture of it too.
You know what, Javon? Just
Yeah.
no.
Okay, so let's find the inverse of this matrix. You ready? I'm going to leave all that up there, the important information.
Okay.
Okay, if
Land on you.
t equals this, 3, 4, -1, 2, then find t to the -1. So that -1 means basically a multiplicative inverse, because what happens when you have a negative exponent? You flip it, right? That's what negative exponents does. So you flip it. So this is the symbol for the inverse matrix of t. Okay? First of all, what's your first step? What are you going to do?
Find the
Sam?
swap the.
Not yet. Before you do that, but you're right. What do you do first, Matthew?
Would you negate everything because it's -1?
Not yet.
You.
Would you
No,
write it
remember
down?
this is just the symbol for the inverse matrix. What?
Nothing.
Would you write it out?
You cry.
Am I in the way? What do you do first, Sam?
Find the determinant.
Determinant. What's 6 minus -4?
Yeah, I would cry first.
10.
I agree.
So it's 1 over 10. So remember, it's 1 over the determinant. Well, the determinant is 6 minus -4, which is positive 10, right? Minus negative is plus positive. So 6 minus -4 is 10, so it's 1 over 10.
Isn't it
All right,
10
now
over
what do
one?
you do, Sam?
Then you swap the 2 and the 3.
Okay, so the 2 goes here and the 3 goes here. What else do you do, Matthew?
Negate it.
Negate what?
The 4 and the 1.
Yep,
it's
so
-4
don't
and
swap it.
+1.
There you go. Now just do the math. What's 1/10 of 2? A tenths is easy because dividing by 10 is just moving the decimal over one place to the left.
0.2.
So that's 0.2. And then that's -0.4. Here's 0.1 and 0.3. That's it. And remind me, when you take the test, there is a typo on the test,
On the next one or this one?
on the next one, when you find and this problem specifically. So remind me when we start reviewing for the test that that's the case.
Okay.
Okay, there is a way to find the determinant or find the inverse of a 3x3 matrix, but you'll need a graphing calculator. So we're going to skip over that. Okay? So let's say we've got an equation, with a matrix equation. So here's what a matrix equation looks like. You've seen it before, like x plus 1, 2, 3, 4 equals 5, 6, 7, 8. And then you can subtract these matrices, but now we're doing them with multiplication. So if you subtracted 1, 2, 3, 4 from both sides, same way you would do a normal equation, and then you get x equals, what is that? 4, 4, 4, and 4. Okay? But that's not necessarily the same process with matrix multiplication, or when you have a multiplicative equation. So let me give you an example.
Okay.
So we're gonna say this. What are we saying? So so 12, 7, 5, and 3 times x equals 2, -1, 3, 2.
Okay.
Okay? So you would think you would divide, but we don't know how to divide matrices. But what's the other option? If you have an equation like this, obviously the easiest thing to do is divide both sides by 3. Or you could find the multiplicative inverse and do that. So that's what we're doing here. We have to multiply by the multiplicative inverse. But it doesn't work this way. If multiplication was not commutative, then we would have to put this guy over here, right? Because if we're multiplying this side on the left, we have to multiply this side on the left.
What is the difference between
In this case, nothing, because normal multiplication is commutative. You can switch the order, it doesn't matter. But in matrix multiplication, it makes a difference.
Okay.
So, let's multiply by the inverse. Can you guys, let's do this. Let's find the inverse of A. Let's say this is A. What's A to the -1? Okay, first step,
Find
the determinant. So 36 minus 35. Oh, that's easy.
Oh.
1. So it's just a big 1 there. Okay? And then swap those, 3 and 12, negate those, -7, -5. So that's it. This is the inverse, because in multiplying by 1, it just stays the same, right? Question?
Well, wait, 12 times. What if it were that it would equal 0? Would then A minus 1 just be the same thing? Except with the places changed?
A to the -1. If this was 0,
Yes.
then you would not, it would not be, it wouldn't work. It would be, if it was 0 on top, it's never 0 on top because it's 1 over the determinant. But if the determinant is 0, then there is no inverse, okay? There's no multiplicative inverse. Well, then you'd say no solution. But, all right, let's move on. So this is what we're going to multiply to cancel this out. If we multiply this side by 3, -7, -5, and 12, but this time, instead of putting it over here, we're going to put it right here. 3, -7, -5, and 12. Well, here's the deal. These cancel, because that's going to give you the identity matrix, right? And identity matrix times x is just going to be x, okay? So now we just have to do this math right here. So let's do this math. 3, -7, -5, 12 times 2, -1, 3, 2. Okay, so let's do our row and column thing. 6 plus -21 is -15. Okay, and then -3 plus -14 is -17. All right, I'm just making sure I'm doing it right. And then the next row and column with the same columns, -10 plus 36 is 26. 5 plus 24 is 29. So there's your answer. That's what x equals. If you did this backwards, you would get something incorrect, unfortunately. But you can check this and make sure it works by multiplying this matrix A times this matrix, and you should get that. If you don't, then you did it backwards. Okay. And the next example is doing that with a graphing calculator, finding the inverse matrix of a 3 by 3 matrix. This is actually kind of a cool way they did this. They made a 3 by 3 matrix out of 3 equations with 3 variables. So you can look at that if you want to, but we're going to skip over that. So if you have questions like that on your homework, you can skip over those problems or just write in the solution. But don't worry about those, okay? So that's it. That's all I got.
Black man, give me some math and I'll give you some flack. Black man.